go forward. Okay. Okay. Yeah. So I'll take. So if Unnithan and Venkat Narayanan both are available, then we can just start with a quick introduction for 5 minutes, and then we can start your session at 4 as scheduled. So I take this as an opportunity to welcome. So we are talking about very interesting session now. Okay. So we are talking about application of artificial intelligence, machine learning, and IoT in supply chain management. So we are here two very senior executives who are the CEOs for their individual organizations, Mr. Venkat Narayanan and Mr. Unnithan. So thank you, sir, for joining. Let me give a quick introduction. Okay, so let me just give a quick introduction. Okay. So Mr. Venkat Narayanan, founder and CEO of Big Tap Private Limited, Singapore. So currently, I think Venkat Narayanan is in Dubai. So he's joining from Dubai. So Venkat firmly believes in using insights based on data to drive decision making at all levels in the organization. This belief guided his entrepreneurial journey, including launching one of the earliest proponents of analytics in Singapore in 1997. Called Knowledge Dynamics. Venkat is also a passionate educator, teaching analytics in IHLs and corporate settings. So very successful businessman. Welcome, sir. Okay. So I would like to introduce Mr. Unnithan. So co-founder and CEO of DBeach Private Limited, Malaysia. Okay. So you are making a truly global event. So Unnithan is a co-founder and CEO of DBeach, brings over 38 years of experience and executive experience and expertise in chemical engineering and business. An alumnus of Harvard Business School and NUS MBA gold medalist. He's a gold medalist in an MBA. He has held leadership roles, including CEO of Corotino Group, a visionary technocrat. He holds 5 patents and is key figure in his oil and fats industry. So welcome, sirs. So over to you. So you have 1 hour to showcase all your expertise, and we'll definitely enjoy your session. So thank you. Over to you, sir, Venkat sir.
Thank you very much. And first of all, just to make sure, I hope I'm audible.
Yes, you are.
Very good. Thank you. Okay. First of all, thanks for inviting us to be part of this session. And me and my co-panelist, Mr. Unnithan, we will focus on sharing our knowledge in the area of how AI and machine learning is used in the context of supply chain. Okay. So the format, the way I want to run through is that I'll spend about 20 minutes or so setting the context of in supply chain, where are all the areas AI being used, as well as IoT being used. Then I would like to invite Mr. Unnithan to focus on one specific aspect, which is around trusted supply chain, okay? Trusted and sustainable supply chains. I'm going to share my deck here. Do let me know if you're able to see that. All right. I hope this is visible.
It is visible. Please go ahead.
Okay, great. Thanks. Again, thanks once again, and good morning, good afternoon, good evening, depending upon where the audience is participating from. So as the introduction happened, right, our focus will be on artificial intelligence, machine learning, IoT, and supply chain management. So before I launch into the topic proper, I'll just spend about a minute or two introducing myself and my company. About myself, I've been in the world of data and analytics for almost 30 years now, and focused only on how data can be leveraged using AI machine learning techniques to meet business objectives. So that's what I've been doing. My company, Big Tap Analytics, is headquartered out of Singapore. It's part of a bigger group of companies called APA Technologies. And we are focused on providing AI/ML solutions globally. And we do quite a bit of work on the supply chain side also. And in fact, we have even developed a standard analytics-driven product for optimizing the inventory and automated reordering in the context of, how do you have an optimal supply chain, which can be deployed in a retailer or an FMCG, etc. Okay, so that's all you're going to hear in terms of, I would say, the advertising break. Otherwise, I'll just uh, deep dive into the topic. Okay. Now, given the nature of the event, I'm sure all of you know what is a supply chain management is all about. But just let me spend about a couple of minutes, more like a refresher. If you look at the key components of a supply chain, you will have suppliers who will provide various kinds of raw materials, which is typically used in a production, creating a product which is a finished goods, which is stored in a warehouse and distributed by distributors using multiple logistics mechanism to the intermediary. In the case of retail, it could be retailer, for example, and from there to the end customer or the end consumer who uses it. Okay. Now, obviously, this is a very simple representation of how a supply chain will look like. In reality, there can be more complex variations of that. So what are the key activities in a supply chain management? Well, the starting point is around planning. Okay. How do you plan for your supply chain, whether it is going to be driven by demand or whether it's going to be driven by supply? How do you plan for all the activities in your supply chain is the starting point. Okay. Now, once you plan, you will get a good idea of what is the demand you have, depending upon what stage of the player you are in supply chain, whether you're a end retailer or a manufacturer or a distributor. The planning will give you what is the amount of whether it is a raw material or the finished goods you would require at different geolocations in what quantities. Okay, so this will lead to your sourcing, and sourcing is where you typically identify the right partner who can be your sourcing partner. Okay? And the next is typically the manufacturing, where depending upon the plan, the raw materials are sourced and the manufacturing will happen, followed by warehousing and distribution, which is the finished goods are then distributed, stored and distributed across the globe, depending on the nature of the business. Okay. So today, most complex supply chains in the world typically tend to be global in nature, where the raw material can come from different countries, production may happen in a different country, or even the production itself can be distributed across multiple countries. I'm sure you all will know about how Boeing manufactures its airplane, where different parts are made in different parts of the world and they are brought together to fit together as a single airplane. Okay? So manufacturing itself can happen in different locations. And then distribution centers in a global or a regional scenario, there can be multiple distribution centers where the products are stored, where they're all warehoused and from there distributed to different levels of your channel, from a distributor to a retailer and so on. Okay. And one of the sometimes ignored component of a supply chain is the so-called return logistics or repairs and returns, which is after an end consumer takes a product, there can always a possibility that something goes wrong and a return is initiated by the end customer. So these are some of the key activities in supply chain. Now, what I'm going to do is I'm going to run through some of the common use cases in AML in the supply chain. But I want to set the expectations right here that the kind of AML use cases you can have in supply chain is literally hundreds of possibilities exist. Various variations exist, multiple combinations are possible, and so on. So it's not feasible in a short 20 minutes or a 25-minute session to go through all of them. So what I'm going to do is that I'm going to take some few key examples and then try to drill down into one example into more detail of how it is done. Okay. So let's start off with the first one, planning. Okay. So in a planning model, what happens is that you start off with demand forecasting. Okay. So demand forecasting is one key area where AI and machine learning models are deployed to go through lots of your historical demand patterns, and on top of it, apply what are called demand drivers. Okay. So what are a demand driver? For example, if you are in the business of selling, let's say, aerated drinks, which is sold in a cold form, then one of the demand driver is definitely weather. Okay, when the weather becomes hot, then the demand for the product will go up, right? Plus, there can also be campaigns initiated either by your organization or your competitor, which may have an impact on it. Let's say you run a one-for-one deal, then there could be a increase in demand. Or if a competitor runs a deal, then it could have a negative impact of your demand. Okay, so which is why the area of demand forecasting is something where AI/ML models are very, very crucial, where these models can go through vast amounts of data sets, which include historical demand, also look at historical stockout patterns. Okay, identify whether there are any excess inventory in any particular location, on based on that come up with a fairly accurate demand for the products at different geolocations or consumption centers. Okay, so that's one example of a AML use case. Now moving on to the second activity of sourcing, to give one example of a use case in sourcing is that in sourcing, organizations want to work with a trusted supplier. Okay, a supplier where I don't want to always go to the cheapest vendor, but I want to have a trusted supplier where I can be sure that the products which are ordered are delivered on time. Okay, so here AML is used, artificial intelligence is used to enhance the supplier performance by looking at their past performance in terms of when the order was placed, what was the committed delivery time, and when did they end up actually delivering. On based on that, come up with a risk rating for the supplier, which tells that this particular supplier, if they are a very risky supplier, is likely to always deliver X number of days later than committed. Now, sometimes even the reverse could be a challenge. If they end up delivering ahead of their committed date, you will suddenly end up having more stock than what is required. Okay, so one good example of where AI used in the context of sourcing is, how do I assess the risk rating of my supplier, looking at their past delivery performance, and then come up with a rating with which whether is this supplier going to deliver on time, deliver late, or even positive case where they could deliver earlier also. Moving on to manufacturing, again, there are lots of examples of use of AI and ML in manufacturing. To give a couple of examples, one is around quality control and defect detection. So where you can use AI-driven inspection system, which either by purely based on data that comes from IoT devices, or by using concepts like image analytics, will help to do a quality control check and identify if there is a defect in that particular in a particular batch, or even a single item during a manufacturing process. Okay, again, to share a very personal example of what we did for one of the organizations which manufactures batteries, we took data driven by IoTs in their manufacturing process after a specific process called welding. In battery, the electrodes are welded to the case. We took the data from the welding along with some related parameters like temperature and others captured by the IoT. And in this streaming data is where models were run to identify whether is this battery going to fail when it goes for QA, or worst case, it clears QA, but it's going to fail when it goes to the field. Moving on to warehousing and distribution. Again, there are multiple use cases. Just to pick one example, warehousing and distribution, you're talking about storing the products, whether it is raw material or finished goods or semi-finished goods, across multiple locations in the geography, and also the need to move them from the current location to the next demand location. Okay. Now, so this requires you to optimize the transportation cost to see how you can optimally route the goods from your warehousing center to the different consumption points as part of the distribution network. Okay, so here AI typically uses delivery route optimization, optimizes the delivery routes in real time, because one of the key requirements in route optimization is to look at what is the current traffic. Okay, in an extreme example, it could be a ship running aground in Suez Canal, or it could be day-to-day examples like in a particular highway there is an accident and there is a buildup of traffic there. So how do I take into account the current things which are happening and also cost into account and improve on-time delivery by using the optimized route? Okay. Moving on, looking at the repair and returns. Here, one of the common use cases to predict the demand for spare parts, because again, repairs are going to happen in multi-location. And typically this is like a dead inventory in the sense that unless the actual product failure happens, that part will not be used. And after a point in time, they can become obsolete also. But that doesn't mean you can't stock, because you may have your warranty commitments or even a monetary for maintaining it after delivery. So how do you use AML to look at historical repair data, failure patterns, and come up with a demand for the optimal number of spare parts to keep at multiple locations for the repairs and returns? These are all I gave in a high level, but I want to just take one and try to drill down into in more detail. So what I'm going to look at is that if you look at all this, right, the common theme is to look at how can I have an optimal inventory, meaning that across my supply chain, whether it is spare parts or raw material or finished goods, I need to keep the optimal amount of inventory so that I don't overstock or understock. So that's a common theme. So how do we do this when we look at across the supply chain to keep an optimum inventory level? Okay. So before I run into the process of how we do it, just to go through the benefits, most of it would be self-explanatory. Obviously, you will maximize profits in this. The reason being is that the less parts you store and keep the optimal amount of inventory, your sales are going to be higher, giving you a lower cost of holding of inventory, thereby maximizing the profits. Okay. And this will help you to improve planning with the accurate demand forecast, improve your inventory management and the inventory turnover. Okay. And while these are some of the positive things, where it can reduce is out of stock. You know, you have a demand and then you suddenly realize you don't have the stock to fulfill that demand. Okay. Decrease obsolescence. You know, if you overstock and that product goes out of fashion or no longer required, then you're carrying a dead inventory, which may end up in probably a write-off, which is the next one, reduce wastage. This typically happens for perishable items. If a supermarket stores a large amount of vegetables or fruits, beyond a level it cannot sustain and it becomes a wastage. Okay? So reduce the cost of carrying excess inventory. So overall, it's about how do I meet the customer demand without overstocking or understocking. Okay? So that's the objective, main objective and benefit of a optimized inventory level. Now, how do you go about it? So if you look at how AI is used, there are a few areas, starting off with demand forecasting. Like I mentioned earlier, a key for optimal supply chain is your ability to do an accurate demand forecast. And once demand forecast is done, you should be able to automatically replace the item at different locations. Okay? And in order to do that, you also need to get a view of what is the inventory at different locations at any point in time, which is where you need a real-time inventory management. Okay? And you need to have supplier, which is where you need to look at the rating of the supplier, do a risk rating to ensure that when I reorder, I'm going to get the goods on the time I'm expected. Okay? And then customer service, right? Because today what happens is that organizations are moving to hyper-personalization mode, where I come up with my supply chain plan based on what is happening, what are the customer demands are happening today to drive the supply chain. So these are some of the data points for consideration. I'm taking a retail example. Obviously, the past sales transactions, which is at the article level or an SKU level, are the key inputs. And then you also look at the current inventory on hand, not just at a store, but also in terms of neighboring store or your distribution centers and so on. Then auto fulfillment data. In the past, when you place an order, how fast did the supplier fulfill the order? And as I mentioned earlier, look at your demand drivers. A demand driver could be like weather information. It could be a location profiling, what kind of a people come to a location, particular location, whether there are holidays in that particular area which has an impact. Let's say you are a convenience store near a school zone. Then if it's a school holiday, there's going to be a dip in demand. Okay. So what are all the demand drivers that have an impact on demand? And something very specific about business. For example, where do you have neighboring stores? Where do you have your company warehouses to determine where the stock can move from? So at a high level, these are some of the data points. In reality, you will have a lot more data points to come in. So how do you then take it? So this process, which is kind of perfected by us, we start by first looking what we call as a out of stock calculation. So for out of stock calculation, we look at multiple things that have an impact on the out of stock. For example, we may have to forecast the footfall to a particular location. In the context of a retailer, we need to forecast the footfall, how many people are going to come in, then do a sales forecast, which takes into account the demand drivers data, and then also look at price elasticity model. Say you run a promotion like 20% discount, then price elasticity model means the demand is going to go up. So take all this into account to come up with the demand at each store level. Okay. Once you get the demand, then you look at the inventory availability based on what inventory you have on book and also physical, because sometimes there could be a gap between physical inventory and on book. Get the physical inventory and in-flight orders, whatever you've placed on your suppliers, etc. Based on that, come up with what is the replenishment quantity required at each store level. So once this is done, then you look at calculating what is called as a threshold. Threshold means, let's say I need 3 packs of, let's say, 330 ml Coke can. It doesn't mean I'm going to order 330 ml Coke can, because I may need to have, I may have concepts like I always need to have at least 2 cans in my shelf. So what is your shelf facing quantity? You may have, contractual obligations that you need to have a particular order quantity, and they can also be pack size, right? 330 ml Coke can will be probably sold only in packs of 24, for example. So we need to aggregate all this to come up with, from a threshold perspective, what is the aggregated quantity? Okay? So these are then taken and applied on the supplier model to say which is the supplier who's going to give it, what is their risk rating. Based on that, we look at whether stock can be moved from one store to another, distribution center to a store, or if insufficient stock is there, taking into account all this, you place an order with your supplier. Okay. I would like to share a case study of where we have done this. This was done in a South Asian country for a convenience store, which has got about 2,400 outlets, and they wanted to streamline inventory management and ensure that out of stock doesn't happen. Being a convenience store, right, they cannot have a large quantity of items to store. And with 2,400 outlets, even if you have space, you don't want to tie down a lot of inventory. Okay. So the business challenges they had was their demand forecast was not very great. Most of the time, as the business leader told me, 7 out of 10 times their demand forecast was wrong. Okay. And customers were coming in and finding that the product they wanted was out of stock. Okay. So we delivered AI-driven automated replenishment system, pretty much using the concept you saw in the previous slide, wherein we were able to accurately forecast the demand at every store, and based on the inventory supplier performance, come up with an automated order fulfillment. Okay. So the kind of tools and techniques we use, we did an advanced analysis to find out what are the variables that influence demand and supplier performance, and then apply AI and machine learning models to forecast the demand, predict order fulfillment time, and take the data from their ERP systems, point of sale systems to gather inventory data, sales data, and use that to drive the automated reordering process. The kind of benefits they got, obviously increased sales and customer satisfaction, and also optimized levels of inventory, reducing both overstock and stockouts. Okay. Now, moving on, I also have to cover IoT in this context. While this comes as a separate topic, both IoT and AI/ML are very closely linked. So here are some of the common areas where IoT is used in a supply chain. One is asset tracking, right? Whatever assets you have in your supply chain, using a combination of IoT and GPS, we can track the location of that product so that you get a real-time visibility of your supply chain, seeing which product is available where. Okay. Next is in the area of cold supply chain. Let's say your COVID vaccines or for that matter, milk, fresh milk, for example, is shipped in reefer containers, refrigerated containers, but then the temperature has to be within a certain range. Otherwise, the product will get spoiled. So IoT is used to measure and ensure that the temperature is within the right range. But as you do that, right, you have to optimize your consumption of utilities like power, water, gas, etc. So here we use IoT to identify various parameters like, for example, in the case of a cold supply chain, what is the temperature? And if it is too cold, we need to bring down the levels by reducing the power to the optimal level so that the power consumption become lower. Another area where IoT is commonly used is failure analysis. Because your equipment has got a lot of IoT devices. It could be, for example, the robots you use in your warehousing. So collecting the data from the IoT devices that are connected to these devices, we use the data to determine and predict when it is likely to fail so that you do a maintenance before it actually fails. So instead of it disrupting your activity, you're able to predict when it's going to fail and do a maintenance before that. Another example is on the fleet monitoring, where the fleet monitoring covers using IoT devices not just to look at where the vehicle is, but also monitor the driver behavior to see, is the driver nodding off, is he likely to go to sleep, and prevent a risk of something going wrong during the fleet distribution process. Okay. Lastly, in warehouse management, having IoT connected to your inventory in your warehouse means you will get a real-time availability of stock, which then will help you to compare against what is really available versus what the book tells you as what is your stock. So much about where AI/ML is used in supply chain and as well as some use cases around IoT. I'm just going to quickly run through some of the emerging trends. One is digital transformation. Today, digitization is happening across the entire supply chain. So where organizations are looking at capturing data in a digital form and not just only data connected to their organization, but also data connected to their customers and suppliers so that they can create what is called as a connected supply chain. So here where AI and IoT comes in is to also help you build what is called as a digital twin, where you can simulate various scenarios for your supply chain using AI/ML models on the digital twin to look at what if there is, the Suez Canal is shut down, what will happen? What if another COVID-19 kind of a breakdown happens, what will you do? So those kind of simulations are possible if you have a digital twin. Next emerging trend is around sustainability, where organizations are looking at sustainable and green sourcing, which is ethical and socially responsible. I'm sure you'll also know concepts like, circular sourcing, where organizations are looking at how do I create a very sustainable economy. Here, AI comes in the context of, as an example, geospatial analytics, which will tell you whether a particular location from where, let's say, the raw material comes in, is there questions around the practices around that place, whether are there any questions around, for example, they're burning trees there, etc., and so on. Next emerging trend is around resilience and trust. Now, recent global disruptions like COVID-19, for example, showed that having a trusted supply chain is very important. Okay, I'm not going to spend much time as Mr. Unnithan is going to talk more about this. So an example of where AI comes in is to determine the risk in your supply chain because of these things. Using of automation and robotics is another example where emerging trend, where robots for warehouse automation and robotic process automation are very common today, and examples include document AI. Then comes hyperlocal, as organizations look to source production closer to the point of consumption. So here, one of the ways they are trying to keep the cost low when they go hyper local, where the cost of product may not be necessarily the cheapest. So they try to optimize, like looking at, can I Uberize the last mile? Okay, which means I don't need to have a dedicated logistic team, but I can rely on a platform where I can have quote unquote people who are available on demand to do my last mile deliveries. And lastly, hyper personalization, where how can I rapidly react to customer demand that is personalized? Okay, here AI comes in to predict the customization demand. Well, if it sounds too easy, then obviously the answer is no. There are a lot of challenges ahead when you're trying to do AML integration in model supply chains. Challenges include, for example, integrating with your existing system. You can have legacy systems where there could be compatibility issue. Data could reside in silos. Some of the data may not be even structured. They could be, PDFs or images and so on. Okay? Then data security and privacy. How do you handle sensitive data? Comply to the protection laws of various locations like GDPR in Europe and so on, and also ensure that you are compliance to the regulatory requirement. Okay? And common to any initiative is, of course, the change management. How does your workforce adapt and accept the new paradigm of using AML-driven supply chains? Okay? So these are some of the challenges. And before I end, just a quick word on, like any field, this is also an emerging field. So these are some of the emerging concepts or emerging trends that are happening in supply chain. One is around AI and autonomous supply chain, where you look at supply chains, we are self-healing. In the sense, these are cognitive supply chain, where agents are able to talk to each other and resolve challenges that happen in the supply chain. Okay. Second is the role of advanced robots, where it looks at, apart from simple automating, look at things like flexible manufacturing, robots which collaborate with each other, and so on. Okay. And lastly, sustainability is now becoming a core business strategy rather than purely becoming a regulatory requirement, or I just need a tick box in my reporting. Okay, so that's about it. What I'm going to do now, I mean, we can come back to Q&A later if all are fine with you, if it's all fine with you, and I'm going to request my colleague and friend, Mr. Unnithan, to take over and run through his presentation.
Thank you very much. So good day, everyone. I hope I'm audible. Can I get a confirmation on that?
Yes, you are audible. Please go ahead.
All right. Thank you very much. So, after that excellent overview that you heard from Mr. Venkat, allow me to share my presentation. Is it visible now? No.
Not yet.
Just give me 1 minute. It looks like I have to go to the...
Is it access rights? Are you able to?
I'm not sure whether I have...
Yeah, you are the presenter now. So on the bottom, you should directly get an option to share.
Yeah, that is what I'm doing now. But
Sure, your presentation is open. Yeah, it's coming
Yeah.
up.
I can see your WebEx screen, not the presentation. Probably it shows the browser instead of the presentation. Share. Stop sharing. Reshare.
Keep the presentation in presentation mode, PPT in presentation mode, and then share it.
Yeah, it is in PPT mode, but It's still showing me this window and not showing me that option to share. Give me a minute. Unfortunately, what I'm sharing is not being picked up in the window.
Not a problem. If you want me to share it from my end, I can do that. Really
Yeah,
no
please do that. It will save some time.
Yeah.
Thank you.
problem. Okay.
Yeah, thank you very much. Yeah, good day, everyone. First of all, I'd like to thank Data Labs for inviting me to make this presentation. The subject that I'm going to discuss uh, is about combining AI, ML, IoT with blockchain for sustainability and trust in supply chains, sharing some of our experience with you on how it is relevant. But specifically, I'd like to touch on two aspects. And the aspects are basically sustainability and trust in supply chains. Through some examples, I will take you through how this can be done. Yeah, you can skip that slide. Let's just end it. Yeah. Now, globally, there is enormous pressure that companies are facing on both regulatory and trust pressures. Some of you who are in the agri business possibly have heard of the EUDR, which is the European Union Deforestation Regulation, that would not allow 7 commodities and their derivatives to be imported into the European Union starting January 1, 2025, without providing due diligence that it has not only not caused deforestation anywhere along the supply chain, but also meeting with several other sustainability criteria. In addition to this, there is the US Forest Act, there is the renewable energy program around the world, something that I'm closely associated with. And then there is the food sector. Why the community at large finds it difficult to believe whether something is truly authentic, whether it is halal food. Kosher systems are more popular because of the very stringent systems that have been established. Now, these are all areas globally that consumers at large and companies involved in these businesses are trying to find solutions so that at the end of the day, they can meet regulatory requirements because that is almost essential for them to stay in business. The second is, how do they ensure trust across the supply chain and particularly with their customers? So, this is the backdrop in which we have to assess the subject matter that I'm discussing today. Next slide, please. So, uh, in the startup that I'm involved with, Dibis, we looked at the fact when we analyzed the industries that we are familiar with, particularly large agri-commodity businesses like palm oil, for example, very popular here in Southeast Asia. We produce 83% of the world's palm, and we export it to around the world, but then two large countries like India and China are the number 1 and 2 consumers of palm, and the third is the European Union. We found that just siloed efforts by a few large enterprises cannot solve the problems of the industry. the need of the hour is really collaboration. How do we make everybody in the supply chain collaborate? Now, when you look at an agri supply chain, you will find that it is very fragmented. At one end of the spectrum, you have smallholders who are uneducated, who have no access to technology. And at the other end of the spectrum, you have large companies that operate ERP systems like SAP. And 60 to 70% of such a supply chain are SMEs who either work on spreadsheets or they have some mini ERP systems that they work with. Now, when you look at such a fragmented supply chain, you will understand that to get all of them to collaborate is a humongous task. And therefore, one way of solving is, how do you digitize activities? Obviously, you need to digitize every single activity in a supply chain to capture as much real-time information as possible. The second, after you have that digitized information, how does that enable collaboration in a fragmented supply chain? Last but not the least, and that's where blockchain comes into play, whatever data that you might present at the end of the day, either for sustainability authentication or for providing trust in whatever form, whether it is for quality, for quantity, or any other parameter that is important for that particular supply chain, you need consensus. And that's where blockchain comes in. So these were the three building blocks of the design that we adopted when we were trying to solve the problem of sustainability and authentication and trust in complex supply chains. Next slide, please. So I tell you a use case that is close to me. I've been in the palm oil supply chain for over 32 years. Prior to that, I was working with Unilever. As you know, Unilever is the world's largest user of palm oil products, a variety of palm oil products. So in all, I have been kind of associated with the palm oil supply chain for a good 38 years, my entire career so far. Now, when you look at a supply chain like palm, as I mentioned to you, you have small farmers that own anywhere between 1, 5, 7 hectares of oil palm plantations, or the very maximum that falls within the purview of a smallholder definition is 40 hectares. You then have large plantations, small plantations. You have transporters that transport a variety of products. And a supply chain like palm is very complex because from one fruit, we get two different kinds of oils. From each type of oil, we can produce hundreds of products, leading to oleochemicals, edible products, specialty fats. So it is very complex to even track anything that happens in this industry in the form of a spreadsheet. Forget about doing anything on a real-time basis. So our approach in this complex supply chain was to create a digital ecosystem, an ecosystem that captures digital transactional data from the very first point of harvesting, as in this case of the supply chain, to shipment of a very downstream oleochemical product like, say, 12-14 alcohols that goes into uh, the personal care uh, or household cleaning products. So what we built is basically a digital transformation tool that allows all the activities to be put and on a blockchain. So that's where we bring about the trust. Next slide, please. So I'd like to spend a little time here on discussing especially the subject that I'm supposed to address during this webinar. And that is that when you capture day-to-day data, it is not just with a view to provide traceability. It is much beyond traceability because now you have digital records of every activity that happens in a very complex supply chain. And that is where we have a number of uses of AI, ML, and IoT at every node of the supply chain. For example, imagine when you look at an agri commodity like palm oil, and you start with oil palm plantations either at the smallholder level or at large plantation level. You now have the ability, not in Southeast Asia, like for example in Malaysia or Indonesia, we are blessed that we get more than 2000 mm of rainfall every year. But there are many parts of the world, for example, in Nigeria or other parts of Africa, where they're trying to grow oil palm, or for that matter in India, where a number of months there is no rainfall. Now, it is so critical from an yield standpoint that you accurately predict what might be the rainfall that you can get, because now there are many IoT devices that allow you to capture soil moisture, humidity levels, and several such data that can now be combined with what, for example, we have built as part of supply chain. And therefore, you might be able to get very granular data applied at every single node to better forecast the weather, soil conditions. You can calibrate your fertilization. Now, if you typically look at most agri businesses, fertilizer is just applied as and when it is required at a certain quantity. It is not calibrated. This leads to wastage. It leads to environmental issues. Now you have the ability to combine AI, ML, and IoT to calibrate the level of fertilization. Another big aspect is the whole world is trying to decarbonize. How do you decarbonize when you do not quantify what is your level of greenhouse gas emissions at the current point in time? This is where, again, when you track real-time information on supply chain, right across the whole supply chain, you're able to quantify the greenhouse gas emissions that are generated at every part of the supply chain. For example, again, talking about palm oil, one of the biggest negative footprints for palm is the methane emissions that comes from palm oil mill effluents. Now, if you quantify all of that, as we are able to do on our platform, to provide a real-time carbon numbering of a shipment of olein or 1214 alcohol that is about to leave the port for Europe, you are actually identifying where is the highest source of greenhouse gas emission, and individual stakeholders involved in the supply chain, then through the data mining of the record that we generate on a daily basis in the dashboards that we provide to these companies, are able to then quantify these emissions and set their net zero targets in a much more structured way, and enabling them to earn carbon credits. In supply chains, pilferage, particularly agri supply chains, pilferage is another big issue. When you have this real-time data captured, you find that you can easily identify when and where pilferage is happening. I think you also heard from Venkat's presentation that inventory cost and optimization is extremely essential. Just to give you an idea, a 1,000-ton palm oil refinery would have possibly 45 million US dollars of working capital required just in managing their inventory. Now, a clear visibility of what is the inventory lying upstream, lying downstream, allows companies, if they are able to shave off even 1 week from the inventory required, that's huge cost saving. Now, this is where real-time applications of AI ML combined with the real-time traceability and immutable data on a blockchain is going to help. What all this means is that one is creating checks and balances across the supply chain. We're getting accurate data to avoid fraud, and we slowly eliminate inaccurate data. And every actor in the supply chain. So the diagram on the right clearly shows you, it could be just a harvester who's using a sickle to harvest the fruit, down to probably somebody who's managing an ERP system of a large company. Each of these actors are involved in generating this data. And when all of this is combined together in the form of a digital platform, one is offering not only customized output in the form of dashboards to individual companies to improve their yields, oil extraction rates, lower inventory. This is where they can see real time benefits. And as we always say, in our particular case, the nominal subscriptions that companies might pay for a platform like this is far offset by the kind of productivity, yield, and other improvements that happen. Next slide, please. So I want to give you just an idea about how sustainability authentication is done on a real-time basis for complying with EU deforestation regulation. Now, EUDR requires real-time deforestation data. Having a disparate deforestation information for a huge parcel of land does not guarantee that a particular shipment that you're sending out is without deforestation. That's how, through platforms like ours, we are able to provide that. We are able to give consignment level traceability despite having hundreds of thousands of smallholders who have never probably used any technology. We provide them with free mobile apps so that their data is captured. What also this means is, when it comes to sustainability authentication, they go through audits, and auditors are paid on a daily basis to go through humongous amount of paperwork to authenticate or provide a certification. All this now can be automated. The entire digital repository of data that they have got allows these auditors and companies to manage their sustainability authentication process very easily. This is what leads to another level of verification of compliance relevant to those certifications that are involved. Next slide. So here is a snapshot of how small farmers who are not at all visible to a supply chain in most of the cases, and they are also not aware of what is the real price of the produce. Now, this has got huge applications, for example, in the Indian context, where we have millions of small farmers, and the issue about minimum pricing to them and how these small farmers can be empowered is a big social mission that we are also trying to enable these small farmers by providing them with free mobile apps that provides them daily insights on what their commodity price is, generates automatic delivery orders. So what they used to write on a soiled piece of paper becomes a part of a real-time digital repository. It allows them to do work by just punching in a few buttons or in their own language. All their records are maintained digitally, and more importantly, this allow companies in the agri field, in the sustainability field, to push information down to these smallholders to enable them to practice sustainable farming, to get better pricing for fertilizers, to get the right kind of agricultural tools, seeds that would help them generate a higher output and operate at a lower cost. So these are all transformational impacts at the very grassroots level of an agri supply chain. I give you an example of agri supply chain only because I'm closely involved. But a platform like what I am describing is completely industry agnostic. All you need is to tweak 20% for its business processes or nuances of supply chain, where the method of production and the complexity might change from one supply chain to the other. But we can apply this to practically everything. Or even if you extend, for example, now EVs are so popular. But have you ever wondered what goes into production of EVs, including where the lithium batteries are sourced from? Where is the lithium coming from? Is it sustainably sourced? What is its greenhouse footprint before it actually gets deployed in a EV? At the end of the day, what we need is a holistic solution that enables us to take informed decisions on whether we're truly practicing sustainability. Next slide, please. So on that note, I would say thank you very much for listening to me. I see on the clock we have 12 minutes. I would like to hand over the control to Venkat as the moderator. Thank you for listening in.
Thank you. Thank you, Mr. Unnithan. Yeah, I would like to open the floor for any questions. Questions from anyone?
So it is very insightful presentation, Mr. Venkat, Mr. Unnithan. Basically, one key question what we get from the organizations is, for a mid-size organization, okay, so how to start the AI journey? Okay, so they are still into the ERP level, the very basic IoT integrations they are doing. But what is the best way for the organizations to plan their strategies towards this? So this is, I think, this is an open question, which people don't know how to do it. So what is your advice? Just can you explain for a couple of minutes? So what is the best way organizations can bandwagon artificial intelligence journey in their organization?
Sure.
Yeah, go ahead.
See, yeah. So today, if you look at it, right, the cloud ecosystems have simplified the cost equation when it comes to deploying AI journey. Okay, because on the on-demand consumption-driven model, you don't need to invest in significant hardware or software in order to deploy AI. So one aspect is definitely how do you leverage cloud ecosystem so that you pay only what you use for. Okay. Now, the second area is that one of the, I would say, uh, misconceptions and fallacy is that you need lot of data, clean data available in a kind of a data warehouse or an environment before you can deploy AI. That is completely incorrect. Okay, because quality is always defined as a fitness for purpose. So what we normally recommend our customers, whether they are mid-size or large corporates, it's all about identifying what are your top 3 pain points today. Okay, and for these 3 pain points, what data I can get from wherever it is and supplement it with data which is available in the external environment, maybe through internet or third-party data providers, and hence we can get started. Okay, that's one way. The other low-hanging fruit is that there are very point solutions to get started. I'll just give you a couple of examples. I mentioned about the optimal inventory management, right? So in our organization, we have built a product called Supply Quotient, which uses AI ML to optimize inventory level by doing a demand forecasting and automated reordering. So if your problem is that, you can go with something like this. This is a SaaS solution where you only pay as you use. Okay. Another example is today Gen AI is very popular. Okay, generative AI. So here most organization can get started by all the documents they have. Like one of our customers in the cold supply chain business, they had a requirement as to how their servicemen who go to a shipyard to repair a refrigerated container can repair without having entire knowledge about the products. Okay, so there is a Gen AI based solution where they can actually ask and get an answer using voice and guide them to repair a particular product. Okay, so to summarize, either by looking at your pain points or looking at your point solutions. So Unnithan, you want to add anything?
Yeah, if I may add, from our experience, especially in agri supply chains, and I go back to what I am familiar with, this industry is very conservative. You talk to them about AI or anything like this, they wouldn't touch any of this simply because they're scared when you talk about such terminology as to how people will adopt. I found one way of getting them interested is first to solve one of their existing big pain points, which is regulatory in nature. Meaning, if you don't solve that, you have no business. That wakes them up. Then they say, for example, now we are talking about EUDR. If you cannot comply with EUDR, you cannot export anything to the EU. Maybe in future you might not be able to export anywhere. So the very existence of business is being threatened. Once you get a foot in the door with that solution, then they already start to see the benefits of the data that we are generating. Then to go to them and say that, look, we add another feature of AI that enhances what already you are getting from our solution, which you only bought for regulatory purposes. You paid a very nominal subscription, but you see the kind of benefit you are getting. Let me allow you to take this to the next level. That is possibly one way we get a buy-in. I just like to add that.
Yeah, that's fantastic, sir. So this one more question I typically get is everybody is interested in the technology, and then they have some specific problems to solve. They want to solve also. Okay, but how how they should do the investment in this direction? Okay, they don't have the ROI kind of idea. Okay, so they still consider this as an expense, not as an investment. So this is a common problem, especially when you talk about supply chain organizations like third-party logistics providers. Okay, so they're still in the beginning of the automation phase. Okay, there are so many thousands of third-party logistics providers which is coming up and helping organizations to achieve excellence. So what is your advice, sir? How can they jump into this from the cost of investment, from the investment point of view? Yeah. Any step-by-step approach? Yeah. Mm-hmm.
Yeah. In our model, as I say that, we are in an industry where even the biggest of players will not spend $1 if they don't need to. This is the reality. In fact, I find it harder to convince larger companies than convince SMEs to look at it, because the whole decision making process is convoluted. They do not do unless they really have to meet a regulatory pressure. Our approach has been that they should be able to see a direct benefit at the point of signing. For example, today in sustainability authentication, every single organization has got a team of 5 or 10 people, depending on how complex their business is, who are trying to do this collation of this humongous amount of data. And it is becoming such a pain that if we go and say, we have a subscription that you get back your money the very first month, because out of a team of 10 people, you just need to save one person and the cost for the platform is paid for. So that is the level of cost effectiveness that you need to build into the offering as a SaaS model. There is no capex, and that gets them interested. But even to get to that point, there is inertia, because they won't do it. Why should I do it if I don't have a need to do it?
Yeah, and I think one more point is sustainability is definitely going to be imposed through the regulatory reforms going forward. So it's a matter of time once we have that sustainability imposition. Okay, so you have to use the technology to come up with the solution. Yeah, so it's a matter of time. So any final thoughts, sir? So we have left with a couple of minutes. So what is your advice for the supply chain organizations, especially the mid-size supply chain organizations?
Sure. So to be honest, in mid-size to small size is honestly where there is going to be a lot of process inefficiencies and ideal to deploy AI ML to get immediate ROI there. Okay, so I would suggest that if, as like Mr. Unnithan also expanded, using SaaS model or cloud model, the investments are not going to be high. To come up with an ROI, it's not very difficult. Just to give an example of that inventory optimization we did for that retailer, just by trying about 10% of the products they sell in only 10 stores, the ROI achieved in literally 3 months. The break even achieved in 3 months. Okay, so in mid-sized companies, it's very easy to achieve ROI. Look for what are your top 2-3 problems, and in order to identify that, compare yourself against the industry benchmark. Like, what is your inventory carrying cost? What's your staff cost compared to the, the revenues and so on, which will help you to identify some 2-3 areas where you can make it better and get started with one of the cloud-based solution where your outlay will be low. And even if it goes wrong, you'll be able to recover fast because you're not invested much in terms of any infrastructure or buying any hardware or software and so on.
Can you hear me?
Yeah, very nice
Yes.
insights. Very nice insights, Mr. Venkat and Mr. Unnithan. So thank you very much for your presentation. It was very insightful. I really enjoyed it. So since we have another 2 sessions remaining today, so all the questions, whatever we get it, we post to you for answer. And you can answer offline. So thank you very much, sir, for joining all the way from Dubai and Malaysia and Singapore. And it's a great session indeed. So we learned really a lot, and we'll enjoy more. We'll come back to you for more information and maybe some more detailed workshop can be required in this to really see the benefit for all of our participants, hopefully in future. Yeah. So thank you very much. Thank you.
Thank you once again for the opportunity. Bye.